Hey, how's it going everyone? Today we're just going to be doing a very basic tutorial on Python, just get a general understanding of its syntax, what it can do, and whatnot. Let's just get started here. So obviously the first thing that we're going to want to do is download Python. So let's go to python.org and go to downloads. So just python.org/downloads, download the latest version right there. After you've done that, we're going to go open up the terminal, type in Python correctly 3. So Python 3, if you have Python successfully downloaded, you'll see your Python version right there. And this activates the interactive Python console. Now we're just going to be using this for the video, and this will allow you to just run single line Python lines and just get outputs quickly and easily, and it's a good way to just test some lines of code and just get a good sense of what Python can do. So it's going to be good for this video. When we get more depth into Python and building programs, we're obviously going to be using a text editor or an IDE, and we'll see that in later videos where we could just execute Python files and write actual Python programs from there. But for this video, we're just going to stick with this. So let's get right into this, and we're just going to look into variables first. So we're going to make a variable named A here. And so we have A as a variable name, and then we use the equal sign as an assignment operator. So what we're going to assign to A is, this is a string. So this will create a string variable, and it's stored into A. And it's denoted by the string variable by using these quotes right here, and we could use single or double quotes. And if we print out A, we could see this is a string. If we want to check the type of A, just to make sure that it is in fact a string, we'll just use the type function here. And this type function is just like a default Python function, and how functions work, or how we could call them, is typically just use the function name here, and we just pass the A within the function parameter, and to pass parameters to a function, you just use the parentheses, as we can see there. So we're looking at the type here, and we see it's a class string. Now, one thing to note is Python is an object-oriented programming language. So what an object-oriented programming language does generally is that it's a framework for programming that bundles related properties and behaviors into objects. So as we could see here, is the string object is bundled in this class, and the object part of it is an instance of the class. So by storing a string object here into A, we've essentially created an instance of the string class. So an instance of a string class is an object of the class. Hence, object-oriented programming language. As we'll see in Python, we like to store pretty much anything into objects. So let's get going here with some other variables, and we're going to look into numerical variables, and so hence the num there, and is equal to 12, let's say. So if we look at the type here of num, we're going to see that it is class int. So we created an int object right here. And conversely, if we want to see another type of numerical type in Python, we could see that appending just decimals here to our number, we get a class float. All right, so in Python we got ints, which don't have any decimals, and then type float, which do. One interesting thing to note here is if we divide, let's say 1 by 1, so we got two integers, and we divide them by each other, and we look at the type of num, and we in fact get a float. And we could see that by printing out num, we get a decimal here. So that's just something to note. In Python, if we take two integers, divide them together, we're always going to get a float. Great. And we could just do some simple arithmetic here. So if we get like a is equal to 12, we get b is equal to, I don't know, 15. And if we do a plus b, we'll see 27. We could do a divided by b with just that forward slash there, and we'll get 0.8, and so on. So it's as you would expect with the arithmetic. You know, we do a times b with the asterisk, and it works out as you would expect. Next variable type, let's create a list here. So let's do 1, 2, 3, 4, 5, and so we have L as the list, the name of our variable, assignment operator again, and we denote the list by using brackets. And each element within the list is separated by commas, right? So if we print that out, we see that we have this list. If we want to retrieve a certain element within the list, we use the variable name here, which is L, use brackets again, and index it by a number that's stated within the brackets. So indexing in programming is, as you may know, it always starts at 0, and then it goes up sequentially. So we got 0, 1, 2, 3, 4, 5. All right, sorry, 0, 1, 2, 3, 4. As the indexing for this list. So if we call 0, we're going to expect to get 1. If we call 3, what are we going to expect? 0, 1, 2, 3, we expect to get 4. And as you can see, that is what we get. We could also have lists. So what you could store in lists, right here we just have a list of integers. But in Python, we're allowed to store multiple variable types within, or I guess a better way to say it is multiple object types within the list. So let's see, we got an integer there. Next element, we'll do a string, right? Next element, let's do a float, okay? And as we can see, if we if we look at the types of each of these elements, so we'll do type, we'll pass the first element here as the argument. Oh gosh, having trouble typing here. We see type int as we expect for 1, and let's do the second one here, and we have a type string, and then we could do the third just for the hell of it, and we should be able to get the float there. So as we'd expect, first one's a int, second string, third float. And so just to display that in a list, we could store multiple object types within it. So let's iterate through this list. And to do this, we're going to be using loops. So loops in Python, there's two main ones, for loops and while loops. Let's try out a for loop here. So that's just denoted by for, and let's say I in L. So this is the header of our for loop essentially. So we have for I in L. So L is our list. So it's going to look at L, and it's going to, within each iteration, it's going to set I as the element in L. So in the first iteration, I is going to be, since this is L right here, first iteration I is going to be 1, second is going to be 2, and so on. And then we have this colon here to end like the header block of our for loop right here. And we're going to go to the new line, and then we're going to indent. So as we indent here, anything that's indented after the header of our for loop is going to be considered within the loop. So it's whatever indented is going to be executed after each iteration, or during each iteration rather. So let's just print I, just to get an idea of what I is during each iteration. And as I said, it should just iterate through the elements of the list L, and I should just be set to the corresponding element of each iteration. And actually, I misspoke a while ago. So this is we actually set L as this later on. So what we should expect to see is just 1, then ASD, and then 12.34. So let's see what happens, and as we expect, we get the correct results there. So now let's look into while loops here. So while loop is denoted by while, and then you have a condition after your while statement, and we're going to say our condition, well, first let's create a variable named a, okay? Let's set that to 5. While loop, so we have our while, and then let's say our condition is while a is less than 20. Okay, so what this is going to do here is the while loop will iterate its statements, whatever in its is within its block, its indented block, as we saw for the for loop here. And so it's going to iterate through its statements while this condition is true, right? So going into this right off the bat, we have while a is equal to 5. So a is equal to 5 initially. 5 is less than 20. Our while loop will start. So that's a good thing. And now, just like a for loop, we indent and we're going to put our statements in here. So one thing to note is we know we want to do something with a. We want to change its value during each iteration some way or another. Because if we don't change a at all, as we could see, the while loop will iterate until this condition is false. And since the condition is true already by going into this, if we never change a, then the while loop will be an infinite loop and it'll never end. And that's not what we ideally want in a program. We want something to happen, right? So let's do this. We're going to increase a by 1 by using the plus equals operator. So when this is executed, it'll just add 1 to whatever a is. And for the next statement, we will print a just to get an idea of what's going on. Now, right off the bat, let's kind of think through this a little bit. So a is 5. We're going in here. We increase a 1. It's going to be 6. We're going to print 6 for the first iteration. Then it's going to go back. It's going to check this condition. Is 6 less than 20? Yes. We're going to go execute this again. Add 1. It's going to become 7 and print 7 and so on. And it's going to get to, let's say, when a is 19, it's going to print 19. Check this condition. 19 is less than 20. Cool. We're going to add 1 to a, which is going to be 20 next. And we're going to print 20. And it's going to go here. Is 20 less than 20? No. It's equal to 20. So it's going to exit this while loop. So we'll expect to see just 6 all the way to 20 when we execute this. And as we could see, that is in fact true. Great. So that's a little bit on while loops. Let's go to another variable type called a dictionary. So a dictionary is going to be denoted by these curly braces right here. And a dictionary could kind of be thought as a list, but each element, instead of indexed by like an integer, as we saw, like 0, 1, 2, 3, and so on, a dictionary is going to be, we're going to essentially label each element within our dictionary. And when we want to retrieve an element from our dictionary, we're just going to use that label that we set it as. So our label could be a string, could also be an integer as well. But let's use a string here, and we'll say, I don't know, like item, so this is, or let's do some concise thing, I don't know, like a num, right? And then we're going to say like 12. And then here we're going to have like some string, and then we're going to have some string, and we'll say like something, some random thing here. Not too fancy, but so what's going on here? We have our label, and our labels here are strings, as we could see by the single quotes. We could also use double quotes again. And then we're going to set its value by, after providing the label, we're going to use the colon and then put its value after that. And then again, we separate elements within our dictionary with a comma, just like a list. And then again, label, colon, our element. Great, so let's execute that and let's retrieve an element here. So if we tried to do what we did with the list and we tried to use an index, we'll see that we get an error. And this is because dictionaries aren't ordered. So lists are ordered in the sense that we can index each element sequentially by going from 0 to however long your list is. Dictionaries are unordered and their elements are only retrievable by using their label that we provided them. So since we provided the num label here for our element that we put there, we retrieve it just like a list, but we use the label within the brackets. And as we can see, we get 12. And if we want to get the whatever this fancy string is there, we're just going to use our string label, and we'll get our fancy string. We could also use like integers as our labels. Actually, let's add an element to this dictionary. So how to add an element is we can just pretend that we're retrieving a variable here. So it's the same syntax. I mean, this will execute if I run this, we'll get an error because 1, there's nothing labeled 1 here. So it'll give an error. But we could assign something to this element that doesn't exist. And you could also assign something to an element that does exist to change its value. But since 1 does not exist, let's set 1 to 12 just to make it confusing here, right? So if we print our dictionary, we see that we have this new element here named 1. And again, the label is an integer type, which is, it's allowed. We could have that. So if we try to index here, we'll get 12. We could also just, to go full swing here, we'll do another string variable, like this item or something, I don't know. And we'll set that to like 45, right? So if we look at our dictionary again, we got a new element called this item, and its value is 45. So that's basically how a dictionary works. And it's useful because you could label your elements. And it's nice if you need to store variables and you want to add a label to each variable so you don't get confused. And a list doesn't work with that because you use it automatically assigns an index to its elements. And so when you want to label your elements within kind of a section of data here, we'll use a dictionary, and that's what that's used for. Let's go to conditional statements here. So as we kind of saw a conditional statement here in the while loop where we were like, if a is less than 20, then the while loop will keep iterating here. But another way to do a conditional statement is using the if statement here. So if, and then we have our conditional statement after the if, and we'll say, well, let's make a variable first here. Let's use a again. So we'll do 12. A is equal to 12 if a is not equal to 12, and not equals is denoted by this operator right here. So we have the same kind of syntax here as our while loop, where we have our statement header right here, and then we go to a new line and we indent. And then whatever's indented here, if this statement is true, then whatever's indented will be executed. So right off the bat, we see that a is equal to 12. And this is saying if a is not equal to 12, then execute this stuff. But obviously it's not equal to 12, so this won't be executed unless we change a. But let's say, so we'll just say a is not equal to 12. So that'll print if that statement's true. And we're going to continue this conditional block right here by adding an else if statement denoted by this elif. So what will happen here is if the statement is not true, so if a is equal to 12 essentially, then it'll jump to the else if statement here. And the else if statement will be let's say if A is, well, this is kind of a bad example, now I realize, because let's just use an else statement. So we'll revisit else if in a second here. But what an else statement says that if the statement here of the if statement is not true, it'll automatically just go to the else statement. And so if A is equal to 12, then we'll print A is equal to 12, right? Cool. And if we execute this, A is equal to 12 because we set it equal to 12. If we set A is equal to 13, and then we run this whole thing again, and you could kind of see that the this kind of interactive Python console here is not too ideal for circumstances like this. But because, we have to retype this rather than copy and paste it. But anyways, as we could see, since A is equal to 13, this conditional statement, or first conditional statement that we denoted with the if here, is going to execute because it's not equal to 12. Let's do a little more practical example here. So we're going to keep A equal to 12. And then we're going to say for our next conditional block here, for the sake of this example, we're going to say if A is equal to like 15, right? So we have not equals, which is denoted by this operator. Equals is denoted by double equals. So this is to not get confused with the assignment operator, which is a single equals. When we use double equals, we're implying that we want to have some conditional statement. So if A is equal to 15, we're going to print, it's 15, right? Something simple. Now, let's use our else if. This is a better way to set this up with an else if, because now we could say, so an else if is just like an if, but it's if the first statement here is false, then it'll go jump to the elif here. And we could put another condition. And contrast with the else statement here, we don't have a condition because that's just how it is. But with the elif, we could have another condition, like if elif A is equal to, and we'll make it 12. And we'll print, it's 12, yay. And we'll have our else statement like we had before, and then we'll just print some like sad face, let's say. All right, great. And it is a sad face. Oh, because we set 8 to 13. I thought it was 12. But so what we have here is, so let's run through this. A is 13, keep that in mind. So if A is equal to 15, no, it's not. We're going to go to our elif. If it's equal to 12, no, it's not. We're going to go to our else. And we have our sad face here. Let's set A equal to 12 and just run this again to get a better idea of what we're doing here with the elif statement. And as we could see, it could be honestly faster in some ways if I type this out again, but it's 12. So we have A is equal to 12. This is false. Goes to the elif statement. Hey, the statement in our elif statement is true. We're going to print it's 12. This is not going to be like, nothing's going to be done with this statement because this is a conditional block in some way. And else if conditional block. I don't know if there's an actual name for it, but there must be. Anyways, so it'll print one of these statements, and it'll print the corresponding statement based off of what our conditional statements within each block is. Great, so those are kind of if-else statements. Just to wrap it up here, we're just going to do comments. So comments are denoted by the pound symbol here. And so when Python's reading code, if it sees the pound or number symbol, it's going to know it's a comment, then it's not going to do anything with the code that's after it. This these comments are here just for you to kind of annotate your code, to give you a better sense of what you're doing, and give other people that are looking at your code a better sense of what the code that you wrote does. And it's also a good future reference when you're going back to some code that you haven't seen in a while, just to just to remember what you were doing beforehand. And it's a good way to use them, because you should use them all the time, because it will save a lot of time and hassle from other people and yourself trying to understand what your code does. So this is a comment. As you can see, nothing happens. We could do multi-line comments by using triple quotes here. As you can see, we have, like, this is a line of comments, and then this is another line of comments, and so on. And so what Python will do here, it'll see the triple quotes, be like, all right, anything after this is a comment until I find another set of triple quotes, and it will do nothing to your code. And this is triple quotes are typically used for, or like the multi-line comment like system here, typically used for like doc strings within like functions and classes, to kind of describe what the function does, and what all the parameters are and whatnot. And we'll see more of that in later videos. And that's all I really wanted to cover in this video. Next videos and going forward, we'll have projects. We'll get more into each of these little topics that we kind of just briefly visited here, and just get a better sense of of how to use Python, how to use it correctly, what you can do with Python. And you could do a bunch of stuff, and that's why Python's one of the most popular languages, and it's fun to use, and you'll hopefully see that in these little videos here. So subscribe if any of that is interesting to you and you want to learn more of Python. Like if you learned something new in this video. I hope it just gave you a brief kind of little sense of what Python's about. And look out for new videos about just more in-depth topics within Python, and also I'll be doing other programming languages like C# and JavaScript, and probably C++ actually. But stay tuned for all of that. This is my first video, so give me some comments below and let me know how I'm doing and what I can improve. I'm sure there's something that I can improve. So just let me know that below, and I'll see you guys in the next video.